Hi, here in this video, I'm going to solve an example of a logarithmic inequality. If you want to know the basics on how to solve logarithmic inequalities, I have created already a video on that. So in this video, we will show one example. So let's start the solution. Solve the inequality log base 10. So we don't see the base, but it's 10. Something that we should always take note. The base is 10 when the base is not written. The log of 3x plus 6 base 10 is greater than log of 4x minus 2 base 10. When solving logarithmic inequalities, the first thing that you have to take note are the restrictions for the values of x. For log, any expression such as 3x plus 6 and 4x minus 2, these expressions should be greater than 0. So 3x plus 6 must be greater than 0, and 4x minus 2 must also be greater than 0. So do this at the beginning so that you will not forget that there are some restrictions for the values of x. Now take note, this is not where all the x will be coming from, but this will restrict the values of x that we can get or that we can consider. For 3x plus 6 greater than 0, this means 3x is greater than negative 6 divided by 3. X is greater than negative 2. So the first restriction is saying x must be bigger than negative 2. If an x is, for example, negative 3, negative 3 cannot be an answer. But 3x plus 6 is just part of the restriction. There's still more from 4x minus 2. 4x is greater than 2. That's plus 2 and plus 2. Divided by 4, divided by 4, then x must be greater than 1 half. So as you can see, from x greater than negative 2, let's say this is the number line. So 0 is somewhere here, and if this is negative 1, this is 1. So 1 half is in the middle of 0 and 1. The first restriction is saying x must be bigger than negative 2. So you can only accept all numbers or the numbers as long as the number is bigger than negative 2. However, we have to take note that that is not the only restriction, as I mentioned earlier. The second restriction says x must be greater than 1 half. So x must be greater than 1 half. So this x greater than 1 half is already removing these options because it says x must be bigger than 1 half. So even if the first restriction says greater than negative 2, it was made shorter because x now should be bigger than 1 half. So the ones allowed for x greater than negative 2, such as negative 1 and all the numbers before 1 half or between negative 2 and 1 half, will no longer be considered. So we have to take note that x must be bigger than 1 half. Now just to provide more idea on how to restrict the values of x, just in case you will encounter in another example. If, for instance, it was an x greater than negative 2 and an x less than 1 half. If this was the case, so this is a what if, just to provide you an idea. The first restriction is saying that x must be bigger than negative 2. The second restriction is saying that it must be less than 1 half. Okay? So the restriction is the one being satisfied by the two. As in this case, this area is both satisfied by greater than 1 half and greater than negative 2. So if we look at x greater than negative 2 and x less than 1 half, the area where both of the conditions are met are in between negative 2 and 1 half. Meaning to say, if these are the inequalities, then the restricted value or the restriction now for x will be that x can only be between 1 half and negative 2. So So when we solve this inequality, for instance, if the x value is not within this interval from -2 to 1/2, then we cannot accept that as a real solution. Okay, but again, take note, this is my what if, just an extension of what I'm trying to explain through these restrictions, x greater than -2 and x greater than 1/2. So let's remove this. So this is not what we need. This is just an additional idea. So for log base 10, 3x plus 6 greater than log base 10 of 4x minus 2, our x can only be greater than 1/2. So what should we do after we have found the restrictions? So again, take note, x must be greater than 1/2. After restricting the x, we can now go to the rule that is set. This is something that I explained in the other video, that for log base b of m greater than log base b of n, if the base is greater than 1, then that means we can preserve the inequality, and this will immediately imply that m is greater than n. Note that this inequality was preserved, that all we have to do to solve this logarithmic inequality is to set the inequality between m and n. Now the case is different when the b is between 1 and 0. If the b is between 1 and 0, if we started with log base b of m to be greater than log base b of n, so let's say the base is 1/2 or 0.5 or 2/3 or 0.25, then this implies that m must be less than n, and the implication of that base between 0 to 1 is that the inequality will now be reversed. So log base b of m greater than log base b of n when the b is between 0 and 1, m, and then reverse inequality with the n. Okay, so this is the main idea. So in this case, we have log of base 10 3x plus 6 greater than log base 10 of 4x minus 2. And since the base is 10, so you have to refer to the base. The base is equal to 10, which is clearly greater than 1. So we have to preserve the inequality when we relate our m. So this is our m, and this is our n. Meaning to say, you have to preserve the inequality and set up 3x plus 6 is greater than 4x minus 2. So we don't have to worry about the log anymore, because the log inequality is now reduced to a linear inequality, which we can easily solve by manipulating this inequality. So here there are different steps that you can perform. Now what I see from the inequality is that I have 4x, which is higher than 3x. So I'll try to set this to 0, or not really to set, but to subtract 3x and 6 on both sides, which is basically transposing 3x and 6. That will be 4x minus 2 minus 3x and then minus 6. So from 3x to minus 3x, from plus 6 to negative 6. Note inequality is not changing. Simplify, so this is 4x minus 3x is x. Negative 2, negative 6, or minus 2 minus 6 is minus 8. And then this is the same as when we add 8 on both sides, this will be 0, but there's an 8. Or in another way of writing this, x pointing to the x less than 8. So this is now suggesting the solution to the logarithmic inequality log base 10 of 3x plus 6 and log base 10 4x minus 2. Now, if you did not set the restriction, you might think that this is already the answer, which is incorrect. Because even if we have x less than 8, we cannot accept all the x less than 8. Because what we said from the restriction is, if this is 1/2 and this is 8, we can accept all numbers greater than 1/2. And the solution is suggesting we accept x that are less than 8. But note, we cannot go beyond 1/2, so the only numbers that we can accept would be numbers between 1/8 and 1/2 and 8. So the final solution to this inequality is actually 1 half to 8, or in interval notation, that would mean from 1 half up to 8. So this is open because we have a strictly less than. So this will be our solution set for the inequality. Okay, so let me summarize what I've discussed in this example. First, there are actually just two things. First is that you have to set the restriction coming from the expressions set in the logarithm or given expressions in the logarithms. The second is know when to change or when to preserve the inequality. And the preservation of inequality or or the reversal of the inequality will base on the base. Is it bigger than 1, or is it a base between 0 and 1? After that, you set up the inequality between the two expressions following the rule given for the two different base that may be used in the logarithm. Okay, so this example, it may be just on greater than, but you can extend this to less than, to greater than or equal, to less than or equal. Just don't forget, when you work on greater than or equal, you have to include the number. Like in this case, if x is less than or equal to 8, then the inequality will now include the 8. So that's 1 half up to 8, and it's a closed interval. Okay, so I hope this example, along with the other videos that I have created for logarithmic inequalities, will be of help if you will be doing or solving logarithmic inequalities on your own. That's all for this video. Thank you.